Okay. Hello, boys and girls. Today we're going to learn about gas laws.
Yay, gas laws.
The first couple
Yeah.
of, we're going to learn 4 or 5.
We're going to
Well,
learn
we
a
already
bunch.
learned Dalton. Yeah, we're going to learn a few more. Okay, so there's 2 guys, gas laws we're going to learn about today. Boyles and Charles. So let's talk about Boyles first. So Boyles Law talks about the relationship between pressure and volume. And this will make sense in 1 second. So you know that when a gas is in a container, right, if we keep the temperature constant, say we're at room temperature.
Okay.
So if I increase the pressure, okay, what's going to happen to the volume? What do you think?
If you increase the pressure, I think that's going to make the volume smaller.
Right, because it means we want more collisions.
Right.
So if there's more pressure for more collisions, it means the volume's smaller. So that's the relationship. Right. So let's draw a graph. So this means that as pressure increases, volume decreases. And this is what you really need to understand. And our graph, if I put volume here and pressure here, will look kind of like this.
Okay, so I see as pressure is increasing across, volume is steadily going down, almost like an exponential thing.
Right.
And we call that an inverse relationship.
Yep.
Right? Okay.
Because they're opposites.
Great.
Okay. So we need to do a practice problem for this one.
All right, let's
do a practice problem.
So let's say we've got a pressure of 1 atmosphere of any gas. We got a pressure of 1 atmosphere, and it's at a volume of 2 liters.
Okay.
All right. And let's say if I increase that pressure to 1.5 atmospheres,
okay,
what would that do to the volume? Well,
rate of 5.
That's a great looking 5. Awesome. So basically, we just want to see what happens to the volume if we increase the pressure.
Okay.
Pretty easy, right?
Let's plug all our numbers in. So I have 1 atmosphere. I'm having problems with this pen. Times 2 liters equals. Well, what do you think is going to happen before we even do the math?
I mean, just like we said, pressure goes up, volume is going to decrease. So I think V2 will be less. I mean, that's just what I think.
Okay. So,
and we're lucky because both pressures are in the same units. We need to make sure pressure and volume are all in the same units. All right, so what, I just multiply those 2 together?
Yep.
1 times 2 is 2.
Divided by 1.5?
Divided by 1.5.
Can't write 5s today. Equals my new volume, which happens to be 1.33. And what are my units?
Liters.
Liters, because I started in liters.
Okay. So our volume decreased just like we thought it did, from 2 liters to 1.33 liters.
Yep.
Pretty easy. There's that inverse relationship. That's Boyle's Law.
Okay, so now let's talk about Charles's law.
Okay, so Charles' Law.
Actually, I don't need to write that.
So Charles' Law was about volume and temperature.
Volume and temperature. So before I even write anything, if I increase temperature, what do gas particles do?
They move faster.
Right, they move faster. So if they're moving faster, they're hitting the sides more. There's more collisions. What do we think is going to happen to the volume?
I think the volume's going to expand because I know this about driving with my tires. If the temperature increases, the tire pressure will increase. Right?
Yep, because the particles move faster.
Great.
So it's all related to that temperature.
So as volume goes up, that's because temperature is also going up.
Right. So one goes up, the other goes up.
Okay. I think I got that.
And our graph for this one looks like this.
A direct relationship.
Yep.
And a little thing you guys should always remember, if 2 things are directly related, you divide them. That's why we have volume over temperature equals volume over temperature. Direct divide. Remember that.
Okay. So now let's do a practice problem. So let's do, what volume and temperature do you want to start at?
Let's say we have a volume of, let's do 2 liters again.
Okay.
We have 2 liters at, let's call it 10 degrees Celsius.
Okay, so we got to convert to Kelvin.
We got to convert to Kelvin, so it'd be 283 Kelvin.
10 degrees Celsius, the first thing I'm going to do is 10 degrees Celsius plus 273 is 283 Kelvin. Don't get messed up with your Kelvin.
Got to have it in Kelvin.
Okay, what do you want to solve for? The new volume?
let's say, yeah, what happens if we increase the temperature to, let's increase it 10 more degrees. Let's make it 293 Kelvin.
So let's say we're going to go to 293 Kelvin.
Great. So what is the new volume going to be? Well, we just have to do volume 1, which is 2 liters, divided by temperature 1, which is 283 Kelvin. We need to have that temperature in Kelvin. And I don't know what volume 2 is, but I know the temperature 2 is 293 Kelvin. All right, so this is pretty easy. We're going to cross multiply here.
So we're going to
283 times V2. So remember how to cross multiply from math. And 2 liters times 293.
So let me show them.
Yeah, let's see.
So we're going to combine these two. Well, that's not going to work. Okay. Let me get rid of that.
There you go.
Undo.
There we go.
Okay.
Awesome.
So you're going to combine. Let me see. What should I do? Just circle it. Okay. So these two.
Right. Multiply those together.
Okay.
Right.
That was way more difficult than it should have been. Okay, and we need a calculator.
I'll run the calculator here. So we're going to do 2 times 293, and that's going to give us 586, and we are going to divide that by 283 just to get our answer.
Okay.
And this is just simple math, guys. That gives us 2.07.
And what are our units?
Our units are liters.
Yep.
Because we started with liters. All right.
So little increase in temperature, little increase in volume.
That sounds perfect to me.
Okay.
So guys, please remember to cross multiply. Please remember that. And if you have trouble with that, please let us know because we can help you. Here's the deal. To show you guys Charles' Law just a little bit, we wanted to show you with balloons. I took 2 balloons. Here's one of them. I blew them up to the same size, and we put one of them in the freezer.
Should I go get the one in the freezer?
Yeah, go get the one in the freezer.
Okay. So what do we think is going to happen?
What's probably going to happen is the volume will get smaller because the temperature went down.
So let's see. Let's put them next to each other. Well, this one's smaller.
This one is slightly smaller. I bet if we left it in there a really, really long time, though, we only left it in there for about 20 minutes. If we left it in there a lot longer, this would get a lot smaller, but I can still feel that it's cold. It is slightly smaller than it was.
Yeah, and if we heated it up, the gas particles would start moving faster, they'd expand, and it would go back to the original size.
Sounds good.
Okay.